Hello everyone, welcome to the Data Flowcast. I'm your host, Marc Lamerty, and today I'm very excited because I'm joined by Christian Schilling and Jens Scheffler, Head of System Testing Automation at Robert Bosch. How you are doing, guys? I'm very excited to have you in this episode.
Yeah, we are doing well. Speaking for Jens as well, thank you for having us here. So we're very excited to talk with you today.
Awesome. Maybe I think so. Before diving into this episode, I just would like to give a quick overview of what you should expect from this episode. So for today's podcast, we will discuss how Bosch leverages Airflow to orchestrate complex testing scenarios for autonomous and driver assistance systems, scaling to millions of tests across both cloud and physical hardware to ensure vehicle safety before deployment on real road. Honestly, I'm very excited about the topic because that's the first time I hear about using Airflow for that. So I can't wait for you guys to tell me how you use Airflow with that use case. But maybe, Christian, starting with you, can you introduce yourself? Like, what do you do at Robert Bosch?
Yeah, of course. Yeah, I'm Chris. It's simple and short is also good. And I'm working meanwhile since 12 years for Robert Bosch. And since 8 years, I have experience with Airflow, using Airflow in the context of automated driving and other systems. I used it previously for data engineering and for a learning loop for machine learning models. And meanwhile, I am the product owner for the digital testing system we are presenting today. And we're using Airflow here for automating all these tests that are needed around other systems.
Okay. And Jens.
Yeah, so I don't have such a long track record, but still, I believe pretty long. So my career with Airflow started at 1.10, and before joining Robert Bosch, I was working in the IT industry for building up large-scale, complex cluster systems and solutions. And from that, I bring in technical architect experience in how to bring up not a big but a large-scale system which is distributed. And yeah, I joined Robert Bosch for especially a scaled out solution for driving test load across big clusters. And initially, the decision went into Kubernetes as a workhorse for distributing the jobs. And we saw that, yeah, Kubernetes is very good for running the jobs, but for doing a workflow end to end, that brought us together and also me to Airflow. Yeah, and so that was the way starting with the challenges. And also brought me in from the point of being a user, deploying that, to being an active contributor in the community, also being very active in the community.
That's awesome. That's awesome. So I guess can you introduce us to your team's work at Bosch, and explain how you are using Apache Airflow for testing automated driving systems? Because again, like this is a use case that I've never heard before.
Yeah, it's also a not common use case, I would say, for Airflow here. Let me maybe start with the introduction here of our team. Yeah, as I mentioned already, our team is working in the ADAS domain. ADAS means Advanced Driver Assistance Systems. And we are talking here about assistance systems in the car like cruise control or lane change assist and the combination of both, for example. And in the levels above about autonomous driving, where no driver is needed anymore, basically, and the car can run on its own. And Robert Bosch is a tier one provider for the actual manufacturers of vehicles. This means Robert Bosch is delivering software and hardware components. And in the ADAS domain, these software components, which are basically the functional code for the car going autonomously. What we are providing as a team is a framework for testing these components. This means our framework is able to do a closed loop simulation or open loop simulation. The difference is in the closed loop simulation, generated data is replayed with the latest software, and in the open loop, case, it is recorded data from the field. And the important thing is this is really with the complete system of the car, software system of the car, and not only with some components. So we are not talking here about unit tests or PyTests. And the important thing is this is really with the complete system of the car, software system of the car, and not only with some components. So we are not talking here about unit tests or PyTests, but really big tests. And for this we need a lot of data. We need a lot of resources, power of infrastructure to do these tests. And we are using Airflow here to automate and scale all these tests. So in the end, we're talking about hundreds and thousands of hours of data we need to replay. And basically, we needed a software tool being able to orchestrate this amount of data and to orchestrate all these different parameters around it. And in the end, the overall goal is to reduce the costs, because when we can run it with Airflow in a virtual environment, we don't need to go to the car each time we have a change in the software. And so we reduce loop times of doing bug fixes, for example, and with that, we reduce the overall costs. Let me give some use cases also as examples here, what these tests are actually. So, for example, we are talking here about data analysis tests. So we have new data from the car, running KPI evaluations on it, and reporting them to a reporting engine in the projects. We integrate our Airflow automation also in the CI pipeline, so for the software integration overall to do these tests. We have the possibilities to provide Airflow to all the developers so that they can also implement some special tests, which are not, let's say, these usual data analysis or integration tests. And in the end, last but not least, and this is what we are really using Airflow a lot for, is these large regression test sets, which are then around 10,000 of hours of data we need to run in only a few days to say, okay, we can release the software, or we can't because there are too many failures in the software, for example.
This is super interesting. I have so many questions already. So just to make sure that everyone understands that correctly. So when you are referring a test, you don't mean like a PyTest or unit test, right? Like you mean a test in, for example, I'm driving my car and there is a dog in front of me. What the car should do, maybe? Like, is that the kind of test you are, doing with Airflow, just to make sure that the system is doing things correctly? That's correct.
Exactly, yeah. So these data sets we're using have different scenes, like, for example, a duck or elephant, maybe not an elephant in these Western countries we have, but having this in front of a car, and there is an expectation how the car should react.
Okay.
And we are testing if the software reacts as expected.
Okay.
Yep.
So I think it is safe to say that Airflow is pretty critical here, right? Because
That's true, yeah. Because without Airflow, basically, we would not be able to run so many data sets in this short time. And yeah, it's very critical for us to have a good result.
okay, that this is amazing. So what makes testing autonomous and driver assistance systems, particularly challenging, and how has Airflow helped address these challenges? Maybe for you,
So
yeah, great.
yeah, so the biggest challenge is really the amount of data we have to run here and the amount of different configurations also of the software we have. So for this, in our projects, we have a setup of that all the functional teams define their test scope. So they are defining the parameters and the scenes they want to replay. And this is done via docs as code approach. So they are writing the test specifications in the documentation. And then we have a tool which is running also in Airflow in our instance, which is interpreting these specifications and is generating test configs. And these test configs we're using in Airflow to massively parallelize then the following tests. So we are running hundreds or thousands of tests in parallel. This is the job of Airflow in the end. And output of each of these tests is actually a KPI or a fail passed decision for a single test. And then with Airflow, we are able to collect all these test results in the end, waiting until everything is finished, and aggregate this to one final decision that we can provide to the project management or to the overall management in Robot Bosch to say, okay, we want to sell or we want to release the new software version. And to do so, a big challenge is actually we need to be fast. We need to be able to run a lot of tests in a short time, but we need to be able to make also enough detail to say how it would run in the car. Because I said we are not running in the car these tests to save costs.
Yeah.
So we have 2 dimensions of tests. And challenges here both must run in Airflow. So we have to run on x86 tests on GPU machines, but also on the actual embedded hardware, which would run in the vehicle, but what we have in server centers. So we need to orchestrate on different infrastructure in even different countries where this infrastructure is. And here we are also using Airflow for. And in the end, what we do with Airflow also in complete on both these dimensions, and this is the orthogonal dimension we have again, is that Airflow has to collect all this data, has to execute these tests, evaluating the results and reporting to other systems as well. So we have to integrate Airflow in complete project tool landscape. And the big advantage we see, especially with Airflow here, is that we have a single point of truth with it because we have one GUI, one API for all the developers to run all these different test dimensions. We can provide a simple way for them to run these tests, even if these tests are very challenging and a lot of dimensions are under it.
And one quick question for you, Chris. Like, you said we have to run many tests in a very short period of time. Like, can you give us some numbers here? Like, what are we talking about?
So normally we have around, I would say, between 700 and 1,000 CI runs per day, for example, where we have to run 20 minutes tests, 700 or 1,000 times. And for this big release test, we need to run around 10,000 of hours in 2 weeks.
Okay.
Yep.
So that's a lot.
And kind of getting to this number, I believe one of the critical factors why we selected Airflow was also that if a test batch is maybe running for 2 weeks, we know that in between the 2 weeks something will break apart or we need to deploy a patch into the infrastructure, we need to reboot the servers. And with Airflow, we were sure that all the elements could be restarted and still driving the tests. I remember a fresh colleague coming in from bit of history, and he said kind of, let's give me a proof that this software can scale and run 1 million of jobs, and I will take a week of time and try to run 1 million of jobs. And he came back actually after 2 or 3 days and was done and said he was convinced that, okay, that thing can scale. Besides, we made it in a way and we've proven that it can scale. And I believe one important thing is also that as a kind of testing platform team, we're not able to drive all the tests on our own. And in previous organizations, it was kind of more in silos. One team was driving the software or creating the software and another team was testing. And meanwhile, it's more or less democratized, meaning the teams which are implementing the software, they need to be capable and be self-sufficient to drive the tests on their own, to implement them and to run them. And with Airflow, we provide the self-service setup so that people can drop in their tests and they can directly use it without the central organization which they are blocked by, so they can directly work.
Okay. I guess like when you say you made it self-serve, do you have like any how did you do that? Maybe in the broad lines, like how people do use Airflow today.
Yeah, so kind of as Chris initially said, kind of we have a docs as code approach where people can write tests, and that's, I would say, the gold standard. People drive and write tests and bring them into the Git repo where they are automatically assessed and generated into test configs. And this should serve for the 80% of cases, and for the 20% of cases where this is not sufficient, people can use the same Git repo and drop DAGs. And so multiple teams, functional teams, develop their own DAGs based on some templates and operators that we have. And that's serving the other 20% of cases. And this serves then for the leftover 20%, 80% of the cases. And then for only the residual, maybe 20% of the 20%, then we develop specific tooling, or they also maybe extend the platform. There also, we have a contribution model, similar like open source, where functional teams, if they need a feature, then they can drop it in and do a PR, and we can validate this.
Okay, this is super interesting because I mean self-serving Airflow in companies is a such critical topic for actually many companies. Like many companies are trying to self-serving Airflow, because obviously you want to make sure that people do things as you expect they do things. So that's why usually you rely on templates and so on. So this is good to know. I guess, like, at some point you mentioned that you were testing different scenarios on both virtual and physical hardware. So could you explain this hybrid approach and why it's necessary for autonomous driving development? Like, why do you have to? Actually, I think you mentioned that at some point, Chris, like why you need to do one.
Yeah, so kind of the challenging situation is we are running on an embedded CPU or ECU. You call it the control unit in the vehicle later on, and those control units, they are on specific hardware. It's not off the shelf hardware. They're running some real time operating system, kind of. Yeah, still it's POSIX, but it's sometimes real time, and so the timing is very important. How the software behaves on the chip. And the chip also has hardware accelerators specific, for example, video decoders and accelerators for artificial intelligence, so that neural networks can be processed in high speed, similar like you do in GPUs with CUDA. But they are very specific to their APIs and to their instruction set. You can simulate this on the x86, but to get an accurate timing, how long some process took to, for example, post-process an image, do semantic segmentation, this need to be time measured. And for everything that's timing related and integration to vendor specific for the ECU instructions, you need to have the embedded physical hardware, as well as physical vehicle buses, like kind of, which is very common, the CAN bus or automotive Ethernet. Those interfaces you can hardly emulate on x86. We try to do most of the tests we can do in software in x86, so we can leverage the cloud and we can scale up and down as we need the hardware. And that's also a perfect fit for like Kubernetes, that you can scale your infrastructure in the cloud and you can distribute the workload. And we can orchestrate with it. And the other way around is when we know that certain tests need to assure the timing is correct, or you need to have vendor-specific hardware accelerators. Those need to be running on the physical hardware. And we try to, depending on the test demand, schedule a test either on one or the other platform. But everything is abstracted. So the user in his test definition can say what he wants to test and how he needs to test it. And then with our testing pipeline, the test is directed to the right hardware platform.
And to add here, maybe another challenge we have is, in the end, both platforms must be somehow comparable, because if one platform would, let's say, lie, then it wouldn't be helpful. So challenge for our team especially is here also to make them comparable and to make them credible for the users.
So I guess, like, during our prep call before recording this episode, I think, like, at some point you mentioned that you were using dynamic task mapping in your tests. And this is a very interesting feature because obviously dynamic task mapping was expected by so many engineers, as you can generate tasks truly dynamically, without knowing the inputs in advance. So it's more complex than just a for loop and generating your tasks. But I guess my question to you is how did the dynamic task mapping help you to solve some challenges that you had with your tests?
Mm. So yeah, as you said, the dynamic task mapping was really a game changer for us using Airflow here, because we had a problem previously, or it's still a challenge. We don't know when we start a testing workflow how many tests we want to run. As I mentioned, the functional teams are defining what should be tested, but we don't know exactly what and how many hours, how many parameters they want to test. So previously, we needed to implement some deck generators with a lot of complex code, a lot of complex functions actually, to say, or to have the possibility to say, I want 10, 100,000 tests. And then also afterwards, it was very hard to report the status of the test because each generated deck was a different deck on a different GUI. There was the report of the status of the task. So yeah, it was really tough and hard to provide this to the users in a experienceable way. And yeah, now with the dynamic task mapping, basically all these problems were gone because we can provide the numbers of tests without knowing before we start the deck to the users. They can use always the same deck. So we have a single API for all the tests they want to do. And we have a single reporting page where they can look, my test was successful or not.
Yeah, I mean, honestly, like for those who haven't tried dynamic task mapping yet, I strongly advise you to at least try this feature because it is, to your point, Chris, it is a game changer feature. Because before dynamic task mapping, you had to do some really weird workarounds, and now with that feature, you can do things in a much easier way. Especially, obviously, whenever you want to generate tasks on something that you don't know in advance.
And it's really strange looking back in the history how we decided to Airflow and use it as an orchestrator, because in the beginning that feature was not there, but still we decided for Airflow. And I remember the times where we had a lot of branching operators and then code generators generating just a graph of tests, which we were not knowing if it's to be executed or not. Yeah, it's really strange.
Yeah, that was painful. I actually started at the same Airflow version than you, Jens. It was 1.10, so that was a painful time for sure. So I guess, like, what I love with your use case. I mean, there are many things that I love, but particularly the fact that I think it's safe to say that Airflow scales, right? Like sometimes you see, I would say, competitors saying that Airflow doesn't scale. I mean, we can agree that it's pretty false here. But I guess, like, scaling is definitely, it takes a lot of trials and errors. And I guess, like, can you tell us more about the challenges that you had when you started to scale Airflow at the level that you are talking about here?
Yeah, so first when we started with the Airflow, we made kind of POCs and we tested if everything runs to expected numbers, but we were not sure to which number it goes to. And kind of one big thing that we had as a challenge for maybe a year, 1.5 years, was that we also integrated Airflow with data events. So kind of, as Chris said earlier in the beginning, we wanted to have pipelines running whenever new data lands from the field. and the volume was constantly by surprise changed, and it was not really between the departments correctly clear when which batch of data will arrive, and we were always faced with event storms unplanned, and that was always giving us a bit of a challenge, increasing the performance and also the scale iteratively. So we didn't do a test initially with millions of tasks because that's far way out of reality. We always adjusted and tuned the system incrementally whenever there was a new challenge. And that was maybe an endeavor for 1.5 years to see increasing volume and then tuning parameter here and there. And it's not easy to make a cookbook because it very much depends on your use case, how the DAG is being modeled, how the events are coming. But we used, the good thing is in this data case, we know a DAG was being triggered when the event came. And then if too many events came, they were just queued in too many DAG runs. And then we just had a peak of jobs and we worked them off. Bit of a challenge was always that Friday evening it was hitting us hard, and then it took the whole weekend to work it off. And then the next week we were kind of trying to improve from increasing database, tuning parameters, scheduling, having more schedulers, and tuning queries going into tracing. So I had a talk on the Airflow Summit in San Francisco, which is also recorded and which I can recommend. That's maybe summarizing a bit of the storyline, and takes a bit longer where we went to. But it was also it's a good example for how we contributed to the community as well, because we saw some queries were not optimal, and then we contributed some fixes and we tuned on all levels. And that's the beauty of open source. You can directly go and trace into the source and you can optimize it where it is needed. Hard to say. So it was in our case an incremental approach where we started with the colleague came in, wanted to have the proof that 1 million tasks were running. We also, of course, did a couple of load test example DAGs to prove that it scales into the needs. But when it comes to real life, you also have the challenge of the backend Kubernetes need to scale, and then you need to archive off data in the background and your queue jobs. And then if the queue is larger, you have side effects. So it's a complex endeavor, but it's also a big learning story on our end.
Yeah, definitely it is hard, and I can't recommend your talk that you did at the Airflow Summit enough. I actually watched it on the official Airflow YouTube channel, and I mean, if you want to learn how to scale Airflow and what are the configuration settings that you can play with, especially for the scheduler, I strongly recommend anyone to look at your talk. This is super interesting. I learned a lot from it, so thank you for that. So I guess, like you mentioned, that you've contributed to Airflow. Can you tell us more about like some AIPs that you did, or because I think like you did some wonderful contributions that's gonna be very useful.
Yes. So for our team, I would say every teammate from our team contributed upstream already. Even Chris as a PO, he contributed also one fix upstream. So we are really in the open source community, and it started on our side with some patches and fixes, of course. And the one thing that bothered me in the beginning was that the log wasn't auto refreshing. So my first PR was a log tailing that you don't need to hit F5 when the task is still running. And then over the time, we wanted to make Airflow better usable for the users. And we had a big debate on how we are doing that. Because if you submit a job in this 1.10 or maybe 2.2 versions, if you submit a job, you can have parameters. And for every manually submitted job, for us, it's important that user can specify his parameters. For example, which Git branch you want to use as a test for his system test, or which parameters for the testing to use. And in the past, it was only possible to provide a JSON dictionary, and then the user needed to know what to put into the JSON dict. And so initially we had a web UI in front for the easiness of the user, that the user has a configuration panel and he can specify what job options he wanted to have. But it was always a bit of a challenge to maintaining another UI on top of Airflow just for users to submit a job. So our first contribution, our first, I would say, really larger contribution was the AAP 50, so that the parameters that are defined on the DAG anyway are being used and treated as parameters to render a form for the user. So today in the Airflow UI, if you press a button and you play a DAG, if you have parameters defined, then a nice form will be rendered where you can specify the parameters and you give the user some instructions. That was one of our contributions, and I'm kind of a bit proud of that.
I think it is safe to say on behalf of the Airflow community that thank you so much for this contribution because at the time where we had to use to put a JSON value, that was so painful and prone and error prone. Thank you so much for your contributions here.
Yeah, and kind of one other AAP which we are working on with high focus at the moment is the so-called edge executor. And that's also kind of, we elaborated a bit about the hardware challenge that we have, that we need to run on physical hardware. And as you cannot rent this in standard cloud, kind of usually everything of our test suites and also the Airflow setup runs in the cloud. But the dedicated physical hardware is very specific to us. So we need to have them either on company premise in our enterprise infrastructure or also on co-located data centers. So it's far, far away from the cloud. And we saw severe stability problems because at the moment we are scheduling everything with Celery, and we are really happy about the scheduling with Celery executor, distributing the workload in the cloud to whatever execution system. But we really had a hard time to schedule workload on physical hardware being stable because via VPN, corporate proxies, whatever enterprise infrastructure that lies between, Celery needs to have a physical stable TCP connection, and then is from the operational quality really giving a lot of headache if you want to have a stable reliant infrastructure. And we were a bit envy about comparing to other, for example, CI/CD pipeline. If you have a GitHub runner, you can set up your own GitHub local runner, self-hosted, and that's only communicating via HTTP. And we thought also this is very much demanded on Airflow having that. And so we started that AAP 69 for the Edge executor, which is a bit experimental. It's in the source tree already, but it's way much more stable for our remote use case. And we use it together with the hybrid execution today in our production already. Even though it's experimental, we are the main contributor there at the moment, but our production farm runs happily and much more stable than with Celery. And for the hybrid scheduling today, everything that's scheduled in the cloud, we use a Celery executor, and everything that's scheduled on the physical hardware, we use the Edge executor quite happily. And that is then officially released with Airflow 3, but everybody who wants to try it out can take it and build it from source at the moment.
Awesome. Well, I don't know what to say. That was a super interesting episode. Honestly, that was one of the most unusual use cases that I've ever heard with Airflow, and that was super interesting. And again, it shows how Airflow scale, and it shows that you can do a lot of different things with Airflow. And thank you for sharing all of your insights and learnings. And also thank you for contributing to Airflow, because again, your contributions have been super helpful. I guess, like, one last question: what is the best way for folks to get in touch with you? Like, for example, if I'm working in, or if I'm very interested by this topic, like, how can I get in touch with you?
I can start. So maybe the best way to get in touch with us is via LinkedIn profiles.
Mhm.
We both have LinkedIn profile. I don't know how we could share maybe the link to it, but yeah, you will find it or find us with Jens Scheffler, Christian Schilling, looking for it, and you will see both of us working at Robert Bosch. Then just contact us, and we're happy to answer your questions.
Yeah, and otherwise, I personally am very active in the Slack community. So kind of if you hit a message in troubleshooting, then it might be very probable that I have an answer on this, or kind of also via Slack, there's a very much a response on it.
Awesome. Thank you so much. Thank you, Jens. Thank you, Chris. That was amazing. I truly hope to see you again for another episode because there is so much to learn in your use case. So we'll see. But have a good one. Take care.